Welcome to the bada video lecture. In this lecture, I'll describe the bada interfaces used for user interactions and the basic building blocks of the UI framework. UI controls are user interface elements, such as buttons, lists, and text fields, and they're used for organizing content on the device screen, providing a means for user navigation or reporting application status changes. Here, I'll explain basic UI components, such as controls, containers, and their usage. The header and footer are at the top and bottom of the form, respectively. I'm also going to introduce the clipboard, which is related to the controls that allow for editing text fields. I'll also explain the list view and pop-up items. First, I'll explain the primitive components of the bada UI and introduce controls and containers. I'll be explaining a few basic controls, such as the header, footer, edit field, edit area, button, and clipboard. Then, I'll show you how to use the list view and pop-up controls. I'm also going to introduce UI event handling and basic controls. Listeners are a very important part of the UI framework, as they notify the application about any user interactions, such as touch or key press events, etc. Let's start with the basic components. First, let me show you how the bada UI layers. A bada application has a top window called a frame. A frame is a window that's automatically generated for each application. The major role of a frame is to contain and show a form on the screen. A form has a title bar, and a header and footer are placed at the top and bottom, respectively. Other UI components are placed at the top of the form. We'll be taking a look at these elements one by one in this lecture. The core components of a bada UI are the frame, form, and controls that refer to other UI components. The frame is the root parent of all UI controls that are created by an application. The frame is automatically created by the bada platform when an application is initialized. It can only contain instances of the form class as its child controls. A form is a full-screen control that you can use to display an indicator area, header, footer, and other UI controls on the screen. The form is the only instance which can be present as a child on the frame control. UI controls are user interface elements, such as buttons, lists, and edit fields, and they're commonly used for organizing content on the device screen, providing a means for user navigation or reporting application status changes. Some controls can contain other controls, and these controls are known as containers. Here's a pictorial representation of a form and its components. Let's have a look at each of these components. A form is basically a unit to manage the screens that appear one at a time. The important feature of a form is that it can be configured according to your needs using an optional indicator, header, and footer. The major role of a form is to contain and manage other detailed controls. We'll discuss more about headers and footers later in this lecture. Let's look at frames and forms in a bit more detail now. A frame is the root parent of all UI controls that are created by an application. The frame is automatically created by the bada platform when an application is initialized. It can only contain instances of the form class as its child controls. To use a frame, you have to get the frame from the application. To do this, you can get the appFrame object by calling the getAppFrame function of the application. You can get a frame from this object by calling the getFrame function. In most cases, a frame is used to manage a form. You can add a form to a frame using the addControl function. The form that's currently being displayed on the screen can be set from among multiple forms using the setCurrentForm function. Next, I'll show you how to actually create a form. You can create a form by inheriting the form class and implementing the virtual functions. The first function to be overridden when inheriting a form is the construct function that specifies the form style. Generally, both the onInitializing function that's used to initialize a form and the onTerminating function that's called when a form is terminated are also overridden. In the onInitializing function, add and initialize the controls to be added to the form. Then, specify the action ID for each control. Finally, register an event listener for each control to finish the initialization. Then, implement the event listener functions to handle events. In the onTerminating function, delete the resources allocated in the onInitializing function if not already done elsewhere in the program. Now, let's take a look at how to implement a form that has a header and footer. To create a form with a header and footer, we've created the form example class as a subclass of the form. The constructor and deconstructor of the form perform nothing. The function onInitializing will be overridden. The onInitializing function is the place to initialize all the other controls, such as the header and footer and any other control that's added to the form. The onTerminating function is called when the form gets deleted, and the callback developer should release the memory and other resources allocated to the heap if this has not already been done. First, let's have a look at the onInitializing function. Here, I've shown the initialization of the header and footer. In this function, we set the title of the header as header and set the footer style as footer underscore style underscore segmented underscore text. We also set a back button to the footer. You can add other controls or perform further initializations at a later stage. I'll explain more about headers and footers later in this tutorial. To make the form visible, we must add the form to the frame. To add this form to the frame, we've created and constructed a form and set this form as the current form in the onAppInitializing function. This part is generally created automatically if you create an application using the application template. The difference is that we have specified the construct parameters of the form as the ORD values. Form underscore style underscore indicator, form underscore style underscore header, and form underscore style underscore footer. This constructs a form with an indicator area, header and footer. As expected, if we remove the form underscore style underscore indicator flag, we create a form without the indicator. To add the form to the frame using the add control method, make that form current using the set current form method so that the form becomes visible. Drawing and showing the frame will display the form. Let's have an overview of the controls now. A control can be regarded as a unit of a UI function. For example, a button, slide, text label, and list view are all controls. Common properties of controls are bounds, event handling, drawing logic, etc. Containers are special types of controls that can contain other controls. Containers have all the properties of controls as well. A container and its control have a child-parent relationship. In general, a set of controls perform a function. Next, let's have a look at the common features of the bada UI controls. First, you can add listeners to the bada UI controls to handle touch, drag and drop, focus, and key events. The geometric functions provided by the controls include functions to set and get the bounds, position, and size, And the contain function is provided to identify if a point is within the control or not. A custom drawing function and a request redraw function to redraw a control are also provided. Additionally, functions to set and get the current state of the control, such as the visibility and the enabled state, are also provided. Functions to manage the name, the hierarchy of the controls, and the life cycle of the control are provided for each control. The onInitializing function is where the controls should be created. All the controls should be created on the heap, as once the control is added to a container, the container deletes all its child controls when it's destroyed. Other controls which are not added to a container should be deleted explicitly. The form gets deleted automatically with the frame. There's no need to explicitly delete the form object. The remove control and remove all controls methods are provided to explicitly delete any controls. The controls, example, the pop-up that does not get added to any container, should be deleted explicitly. Here, this example shows how to create a label and add the label to the form. A new object is created on the heap, and then the construct is called with rectangular coordinates and the text to be displayed on the label. The add control method adds the label control to the form. Now, let's look at the headers, footers, and a few other simple controls. As the name suggests, the header is placed at the top of the screen and the footer at the bottom. A header is normally used to display the description of the current screen, and it can also support buttons in the left and right corners. A header supports multiple styles. The header underscore style underscore segmented supports up to 4 segmented items and can be placed in the center. In addition, you can also use one button item on both sides of the header as long as the total number of items does not exceed 4. The header underscore style underscore title can be used to display the title in the center. In addition, you can use one button item on both sides of the header. The header underscore style underscore title underscore button displays the header title button in the center. One button item on both sides of the header can be used with this style as well. The code snippet shows a simple implementation of the header. First, get the header object by calling the getHeader method. Then, set the desired style using the setStyle method. The snippet shown sets header underscore style underscore title as the header style. Using the setTitleText method can set the title. The footer is situated at the bottom of the form. The footer can have different styles, such as segmented text, button icons, etc., which can be set with the setStyle function. The back button event is passed to the registered listener. A footer supports different styles. The footer underscore style underscore button underscore icon style supports up to 5 footer button items with icons. In addition, you can also include a back button as long as the total number of items and buttons doesn't exceed 5. The footer underscore style underscore button underscore text style supports up to 4 footer button items with text. In addition, you can also include a back button as long as the total number of items and buttons doesn't exceed 4. The footer underscore style underscore segmented underscore icon style supports up to 4 segmented items with icons. In addition, one button item can be added on both sides of the segmented items as long as the number of segmented items doesn't exceed 2. The footer underscore style underscore segmented underscore text supports up to 4 segmented items with text. Here, one button item can be added on both sides of the segmented items as long as the number of segmented items doesn't exceed 2. The footer _ style _ tab supports up to 15 tab items. Button items cannot be used in addition to tab items. The code snippet shows the implementation of a footer. First, to get the footer object, call the getFooter method. The setStyle method sets the style of the footer as footer _ style _ segmented _ text. The setBackButton method adds a back button to the footer, the events for which can be received in the listener added by the addActionEventListener method. Now, let's look at the controls which allow users to type and accept user input. Edit field and edit area are these types of controls. The edit field and edit area controls have listeners that report text changes and other related events. The interface is iTextEventListener, and it supports the onTextValueChanged callback and onTextValueChangeCanceled callback. The onTextValueChanged callback is called when there's a change in the text value of the editable area. The onTextValueChangeCanceled callback is called when a user selects the cancel button of the editable area. The process of creating and adding the edit field is similar to what we saw in the case of a label earlier. Here as well, the object is created on the heap, constructed at the proper size, listeners are added, and finally added to the container. Every control can have a name associated with it, and in the example shown, this is achieved using the setName function. The listener is usually an object that implements the callback associated with a particular control. Every control has the addEventListener and removeEventListener functions. The listener functions are appropriately named according to the type of event. The lowest level event listeners that every control has are FocusEventListener, KeyEventListener, TouchEventListener, and DragDropEventListener. Additionally, each control has an event listener specialized for the control. Here, we can see that the listener associated with edit field is iTextEventListener. The form class is derived from the listener class and implements all the pure virtual functions. In the onInitializing method, the edit field is constructed with the specified rectangle. In order to register for the text events, the edit field calls addTextEventListener with the argument as this pointer, which means that the current class will receive all text-related events from the edit field. The setName method sets a name for the control, in this case, the edit field control. Finally, the edit field control is added to the form using addControl. The appropriate callback is called for each event. Here, I've shown the implementation of the onTextValueChanged event handler. In case multiple controls have the same listener, the getName function can be used to distinguish and identify the control that's actually causing the event. Buttons are another very basic and integral part of the UI. Buttons support click events. A button has many properties related to its appearance in terms of the background bitmap, text, and color. The button properties can be different for different states, such as the normal, disabled, pressed, and highlighted states. iActionEventListener is the interface for button click events, and this interface provides the onActionPerformed callback. This example shows the creation and initialization of the button. Here, the button is constructed with the specified rectangle and no text. The setNormal bitmap method is used to set a bitmap at a specified position on the button. The action ID is the value passed to the button click event. Add action event listener adds the listener object as a listener and passes the button click event to it. Finally, the button is added to its parent using add control. The clipboard is used to copy and paste data between or within applications. The clipboard supports multiple data types. Simple data types such as text and images are stored directly in the system clipboard, while more complex data types such as video and audio are stored in the directories maintained by the clipboard. The clipboard can contain a maximum of 5 items at a time. When a new item is copied to the clipboard, when it's full, the oldest item in the clipboard is automatically removed. Each item in the clipboard has a specific data type, and only data that matches the data type can be stored within that item. The text data type represents simple strings, which are stored in the clipboard as is. The image data type represents bitmap images, which are stored in the clipboard as instances of the bitmap class. The audio data type represents audio files, whose file path is stored in the clipboard. The clipboard only supports the copy and paste operations for audio files stored in local storage. The video data type represents video files, whose file path is stored in the clipboard. As for audio, the clipboard only supports the copy and paste operations for video files stored in local storage. The HTML data type represents full HTML documents. The source files of any images included within the HTML document can be stored locally or remotely. The local image sources saved in the clipboard directory are used by the web browser and the web control. Let's look at one example of a clipboard. Here in this example, I've shown how to copy an audio file and how to retrieve it. First, we need to construct a clipboard item with the audio file. Clipboard item is the data handling unit between the system clipboard and applications. Now, we need the instance of the clipboard, which we get using the getInstance method, and then using copy item. We can copy the specified item to the system clipboard. Next, we need to retrieve the data where we need to paste it. For that, we use the retrieve latest item n method, which retrieves the collection of items that matches the specified data types from the system clipboard. In this example, we've specified text, audio, video, and HTML. Once we have the collection of items, all we need is to get the data from the clipboard item, which I have shown here using the getData method. The getData method will return the data as a string, which in this case is the audio file path. Once this is done, the clipboard item object is deleted. Next, I'm going to discuss the list views and pop-up controls. List view and pop-up are two basic controls which can be used in many application scenarios. The list view control is used to display a list of similar items. The pop-up control can be used to display any kind of information to the user when the application is running. List view is a UI control that's used to control the way in which a list is displayed. The list view represents a list which loads both simple and user-configured items when they need to be shown. A simple item has a fixed layout consisting of a bitmap and a text string. A user-configured item in a list view can have a different layout and height as compared to other items. The item of a list can be scrolled to view other items if the whole list is too large to fit in the screen area. There are 3 different types of lists: list view, grouped list view, and icon list view. A list view represents a list of items, which loads both simple and user-configured items when they need to be shown. A simple item has a fixed layout consisting of a bitmap and a text string. A user-configured item in a list view can have a different layout and height compared to the other items. Each user-configured item is composed of elements, which can be text and bitmaps, and is configured using custom item. When it shows items on a screen and the items are not available in memory, a list view requests an item provider, which is registered by the construct method to generate an item corresponding to the given index. A grouped list view represents the grouped items in a list. The items in a grouped list control consists of groups and items. A group represents the grouped items and is placed on the first level. The group consists of a simple or custom item. Therefore, items are uniquely identified with two indices, a group index and an item index. An icon list view is used to display a list of bitmap images and icons. It can be of different styles with a vertical or horizontal scrollable facility, and its items are capable of generating UI events, such as selected, checked, unchecked, etc. Now, let's look at the steps which need to be followed to implement a list view. First, a class usually derived from a form, the event listener, and item provider listener are needed. Then, the list view is constructed and added to the form. The iList view item event listener and iList view item provider listeners are registered to listen to events. Finally, all the event handlers should be implemented. We'll take a look at these steps with sample code shortly. A list view needs the item provider interface implementation to generate items for the list view. A list view calls the item provider to request an item which is about to be displayed on the screen. Applications which use list view must implement the item provider. The first call is to get the item count via getItemCount, and the application should return the total number of items. Then, createItem is called for each item as and when they become visible. The deleteItem callback is called when the list item becomes invisible due to scrolling. Different callbacks are associated with different events. For example, if an item is touched or its selection status has changed, the onList view item state change function of the iList view item event listener class is called. The source control, index, item ID, and state are passed through the parameters. The source control parameter is the list. A list view also provides notifications of swipe events of list items through the onList view item swept callback. Context items become visible after a user swipe, and a user click on context items provides the onList view context item state changed callback. There are two types of list items that can be added to a list view: the simple and custom list items. A simple item provides basic elements such as text, bitmaps, and an annex style. A custom item can have many elements and supports custom drawable elements. A simple list can be used to display text with a different style. Available list styles include the normal style, styles for radio actions, and styles with a check or on-off mark. As the image shows, the list _annex _style _mark, it displays a tick mark on the right, which can be checked or unchecked. The list _annex _style _on-off _sliding displays a sliding on-off style control. Here's an example where the form is derived from the iList view item event listener and iList view item provider. The iList view item event listener provides the callback for events of list view items. For example, item state changes. The iList View Item Provider provides callbacks related to creating items. For example, create item, delete item, and so on. Here, we can see that the list view is constructed with the specified rectangle coordinates. The set item provider registers the item provider callback for the item creation. The add list view item event listener registers the callback for item events. Then, the list view is added to its parent using add control. Okay, let's have a look at the implementing listener now. Get item count is called first, which returns the number of items here, say 10. Next, create item will be called for the items which are to be created, though this callback may not get called for each item as all may not be visible at once. After the list is scrolled, create item is called for new visible items, and delete item is called for items that have become invisible and need to be unloaded from memory. Now, I'm going to introduce the pop-up control. A pop-up is different from most other controls, as it's derived from the window class. A window is a container class that's used directly and not included in another container. Therefore, as the window can be displayed on the screen without being attached to another container, the developer must manually delete the window when it needs to be removed. The window class has the pop-up, message box, context menu, and time picker subclasses. Now, pop-up is a window that's located at the center of the screen, covers a part of the screen, and is modal. Okay, let's look at how we can create a pop-up. In general, you can create a pop-up in any part of a program. First, create and construct the pop-up. Then, set the pop-up title and add additional controls to the pop-up. Since in most cases a pop-up has simple buttons such as the OK and Cancel buttons, create these controls, add a listener to them, and add them to the pop-up. Then, display the pop-up on the screen. As I mentioned previously, a pop-up is a modal window. It cannot receive input from another part of the screen. Therefore, controls on the pop-up should be used to remove the pop-up. So add the OK and Cancel buttons, and make the button listeners hide the pop-up. Finally, if the pop-up is no longer necessary, the developer should manually delete the pop-up. Let's have a look at an example of creating a pop-up. First, create a pop-up in the heap and construct it by specifying the size. Then, set the pop-up title and create a button called Push. Assign a D and an event listener to the button, and add the button to the pop-up. This completes the general pop-up creation procedures. If the pop-up is to be displayed on the screen in a part of the program, you can do this by setting the Set Show State of the pop-up to true and calling the Show function of the pop-up. We've implemented the code to make the pop-up disappear when a button in the pop-up is pressed. When the button's pressed, the show state of the pop-up is set to false, and then the form below the pop-up is drawn and shown so that the pop-up can be removed from the screen. Finally, if the pop-up is no longer required, you have to explicitly delete the pop-up. Bada supports a huge number of UI controls, in addition to what we've seen in this lecture up until now. Let me just briefly to show you a few other controls. Here, I've shown you a few controls that accept input. Color Picker allows users to select a color. When initialized, color pickers always contain the full set of 3 sliders that affect the color hue, saturation, and luminance. Sliders can be used to allow users to change values by dragging a slidable button within a horizontal scale. They're commonly used to provide users with an intuitive way to change the value of a parameter, such as the application volume level. Edit time is a fixed size UI control used to display a time value. It has 3 parts: minutes, hours, and the AM or PM value. There are a few controls which are meant only for display purposes and which do not accept user input. For example, progress, label animation, etc. The progress control is used to indicate the progress of an operation to the user. The progress is a horizontal bar, very similar to a slider, except it's generally non-interactive. The text box control is a non-editable text field UI control that you can use to display static text on the screen. A text box can handle a larger amount of text. If all the text doesn't fit within the text box area, a vertical scroll bar is automatically enabled in the text box, and the user can scroll up or down to view the entire text. The animation control can display a set of still images as a scrolling animation. Animations function by assigning image files to animation frames, and then arranging these animation frames in the required order. The frames are displayed one at a time as a series. Bada also supports controls such as the flash control to play flash files and map controls to display maps. The flash control enables an application to play multimedia content, such as flash videos or flash animations in your application and interact with flash content. The flash control supports the man-machine interface, MMI, enabling the flash control to interact with the flash content. The flash control supports the get and set settings for how the flash content is played, such as the volume level and repeat mode. Using map controls, you can customize maps and provide people with additional information and map interactivity. Map controls can render maps and draw multiple layers step by step, and they can also display information windows, which provide information about places or map features. The map control supports the overlay of various shapes to provide additional details for the map. The map controls are part of the location namespace. In this lecture, we learned about the roles of a frame and a form in the bada UI framework, as well as the UI listener interface that's used to handle UI events. We confirmed that all controls handle events, such as the focus, touch, key, drag, and drop events. And we learned that each control requires specific event listeners. We also saw actual examples of lists and pop-ups. The list view class provides functions to display multiple items in sequence, and the pop-up class provides the modal window function that's generally used in a UI.